Welcome to week 1 of the project, and I sincerely hope that this is not what you look like right now. Let's begin. Now, this video will be covering the theory behind inter-process communication, and mind you, the example of inter-process communication here is about processes running on different machines but connected to the same network. Before you proceed, it is recommended to watch the first video if you have not so far, because this video builds up on the concepts of the first video. If you have, I would like to tell you that networking may seem daunting at first, but thank God for extensive documentation. You do not need to remember everything. That said, the more you know, the less you know. But that applies for almost all fields of learning at this point in time. So do not fear the fact that there is so much to learn. Learn only what needs to be known. A quick recap. We'll be using a monosec server which will throw results to the monitoring client. And we know that the monosec server captures almost all packets in a network. So basically, our objective is to achieve successful communication between a process running on the monosec server and a process running on our monitoring client. Now, for this successful communication between the client and the server, some setting up needs to be done. Because if there is no setting up, there would be no rules in the network, and that would basically mean, at least theoretically, that the network is being flooded by all sorts of random communications. This setting up is necessary and is done by certain function calls. They are not necessarily operating system specific. For all those who have watched the first video, when we say inter-process communication, it must ring a bell that when two processes are involved in communication over a network, the transport layer comes into the picture, which defines a port number for communication. I'm not sure how many of you are familiar with the concept of a socket, but a socket is a communication endpoint which identifies a communicating computer. We will see how that works. There are two types of sockets. One which is connection oriented, as demonstrated by TCP. The other is a connection less oriented socket, which is demonstrated by UDP. Let me give you an example of a connection oriented socket. Suppose you have a server trying to communicate with 4 clients at the same time. Let us take client 1's request for communication. Since these are connection oriented sockets, they are very particular about connection establishment followed by data transmission followed by connection termination. So let us see how a connection is established between a client and a server. Step 1. The client says, "Alright server, I need to connect to you." In the second step, the server says two things. First, it says, "Yes, I acknowledge that you wish to connect with me." The second thing it sends is that "let's connect." So it acknowledges and initiates its part of the connection. The third step involves the client acknowledging the second step sent by the server. That "yes, I received your communication, so I guess we are ready to transfer data to and from each other." So this is connection establishment. Notice that this is a 3-stage process. As a result, connection establishment through connection oriented sockets is a 3-way handshake. Now let us assume that the data transfer has been done, and now the client wishes to terminate the connection it had made with the server. Now these are the following steps which are followed. Client 1 says, alright server, I'm done here, I need to go. Well, the server in response says, alright client, I acknowledge your request that you need to go. At the same time, the server says, alright client, since you told me to get lost, well, I'm going offline, at least for you. The client, finally happy with whatever he received from the server, says, alright server, you're free to go now, I don't need you anymore. So this is step 4. As you can see, the different colors indicate each stage of connection termination. Needless to say that connection termination in connection oriented sockets is a 4-way termination. Moving on, we have connection-less oriented sockets. As the name suggests, these type of sockets are not very particular. In fact, they are not particular at all about establishing a connection, transferring data, and then terminating a connection. There are no boundaries in a connection-less oriented socket. To give you an example, in the connection-oriented socket model, you had the client requesting something and the server acknowledging the client's request. But now, all we have is the client sending something to the server not acknowledging the client's request. Instead, the server just sends whatever data was requested. Please note that the client finally gets the data it requested, but it does not get an acknowledgement from the server saying, hi client, your request has been received, I'm processing your request, please wait. It does not care, neither does the client. Moving on, here is a seemingly complex diagram, but once we go through it, it will make things very clear for you. On the right side, we have a client which intends to communicate with the server. These are the function calls which are not operating system specific. So if you are running Unix or Windows, they are bound to run without any errors. Let us begin with how the setup works for the server side. Well, you create first of all a socket, because that is the endpoint of communication. So you create a socket using the socket function call. Second, we need to bind the socket. Now this bind function call is something you will be encountering throughout your networking course. Since you know that you can connect your laptop to the Ethernet or through wireless onto the internet, there are different interfaces a computer can use to connect to a network. It can be wired, it can be wireless, as I just mentioned. So you need to bind a particular socket which was created to an interface. That is done using the bind function call. Now this is clear. Since the server is a computer exclusively made and tailored to accept connections from clients and serve their requests, it has to listen on the network for any incoming requests. To be more clear, the listen function call makes sure that the first step of connection establishment goes successfully. Once connection establishment is done, the server can accept that connection using the accept function call. Now coming to the client, as you already know, a socket needs to be created before communication can begin. So that's the same as the server. Followed by the client requesting to connect to the server using the connect function call. This is where connection establishment takes place. Followed by the client and server communicating among each other for any type of data transfer. And the cycle goes on and on and on. This repeats until the connection is terminated by either the client or the server. Moving on, we will be using the IP version 4 socket structure because it is easier to work with. It contains the following. Any socket contains the 32-bit IPv4 address, the length of the structure, the family of the internet protocol used. It can be either IPv4, IPv6 and so on. And lastly, it contains the port number being used for communication. To give you a demo, I'll show you the interfaces which run on the computer. This is my Ubuntu virtual machine, and let me open a terminal. If I type the command ifconfig, you can see a whole lot of information being thrown at you. The first is the type of interface. In my case, I am using the Ethernet interface, for which I have been allotted an IP 192.168.11.5. There can be other interfaces such as ETH2, ETH1, ETH0 in the case of Ethernet, or WLAN 0, WLAN 1 and so on in the case of wireless enabled laptops. This LO here stands for the loopback interface, where you are allotted a link local IP address to loopback. That's 127.0.0.1. Now I have an HTTP server which is running on my Windows 8 machine right here. This is the folder which serves index.html and the IP is as follows: 192.168.11.4 : here is where I am specifying the port number. It is an HTTP server, but I have configured my port to be on 8051. So if I do that, I get the HTTP server saying get a text file here, and the text file is served when I click on it. So there you go.